last up, we have a subtraction problem we want you to look at. So over here, we are subtracting 7/8 and 3/5. And just like with addition, you'll notice we had to multiply by a fancy version of 1 to make the denominators equal the same thing. So we times 8 by 5 and got 40. We times 5 by 8 and got 40. And once we have the denominators the same, we do basically like we did with addition and write a single fraction with the numerators being subtracted. And then we subtract them and see what we get. So let's try it out here. Now I have 3x plus 1 over x plus 5 minus x minus 4 over x minus 2. The denominators are not equal, so I need to make them equal by timesing by that fancy 1. So I'm going to times my 3x plus 1 over x plus 5 by x minus 2 over x minus 2. Okay, and the idea is by multiplying by whatever the denominator is of the other one, then the denominators will be the same when I get to the next step. So I'm going to multiply by that on that side, and then for this term, I'm going to multiply the top and the bottom by x plus 5. And when I do that, now my denominators are going to be equal. The next step is I multiplied things together. So on the top, we get 3x times x is 3x squared. 3x times negative 2 is negative 6x. 1 times x is 1x. And 1 times negative 2 is negative 2. Now the bottom one, I'm actually not going to multiply together. I'm going to leave it factored out because there's not really any point. I don't have to add anything to it. And I actually, in the end, want to see if I can simplify anything out. So it helps to leave that factored so it's easier to check for anything that can simplify. And on this side, we're going to have x times x, which is x squared. X times 5, so 5x. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. And then again, the bottom here, I am going to leave as x minus 2 times x plus 5 because I'm going to want to see if anything factors in the end. So I'm going to leave it factored out. Now the next step is to write a single fraction with the numerators being subtracted. And on the bottom, I'm going to have x plus 5 times x minus 2. Or if you prefer, you can put x minus 2 times x plus 5. Doesn't matter. And then on the top, I'm going to subtract these two things. So I want to do 3x squared minus 6x plus x minus 2, and then subtract from that x squared plus 5x minus 4x minus 20. Now it's important to put parentheses around this because if you don't, it's going to look like you're just subtracting the x squared, and you're not. You're subtracting everything in here. So those parentheses are to tell me that that negative actually belongs to everything in there. So if you want to write it without the parentheses, you have to distribute that negative to everybody. So you could write negative x squared minus 5x plus 4x and plus 20 because that's passing that negative out to everybody that it belongs to. But make sure that you're subtracting everything. So on the next step, we just do that subtraction. And when you do subtract those, you do in fact get this. Let's maybe walk through it over here on the side. So 3x squared minus x squared is going to be 2x squared because you have 3 of the x squareds and you're taking away 1. So that leaves you with 2. And then we have a negative 6x and we're taking away 5x. So if you have negative 6 and you take away 5 more, that's negative 11 x's. Then I have 1x minus negative 4x's. Now subtracting a negative 4 is going to be like adding a positive 4. So 1x plus 4x is 5x. And last we have negative 2 minus negative 20. And again, Subtracting negative 20 will be like adding a positive 20. So negative 2 plus 20 is positive 18. And then if I combine the x terms together that I didn't combine up here, negative 11x plus 5x is negative 6x. And so this, in fact, does equal that. So everything checks out. Now, they went ahead and factored the top also and ended up with this. Now, only a 2 factors out. You can't really split this up anymore because there aren't any whole numbers that multiply to make 9 and add to make negative 3. So that quadratic there is a prime quadratic. It doesn't factor anymore. And so that means there's nothing that's going to cancel out with the bottom. So if you wanted to at this point, you could put everything back together, or you can leave it like that. It just depends on what you're doing with it, right? Depending on what we're doing with this, we'll know what we need and what form will be most convenient. So this might be perfectly fine. This might be perfectly fine. Multiplying the bottom together might be perfectly fine. Just depends on what you want. There you go. There's your subtraction. Basically just like addition, except we had to subtract two polynomials instead of adding them. But be careful because that is where most people make their mistakes, is in subtracting the polynomials.